So I'm going to go over each. No, I don't want to open that. I'm going to go over each one of these with you. So let's take a look at I2. Is I2 polar or nonpolar? Nonpolar because it's the same atom bonded to itself and it has the same electronegativities. So that means when you subtract them, you get a nonpolar bond. Okay? So what do nonpolar substances have?
London dispersion forces.
Exactly. London dispersion forces. Okay. HF. Polar. What intermolecular forces does it have? Let's list all of them.
Hydrogen bonding, dipole, LDF.
Yep. Hydrogen bonds, dipole forces, and London dispersion forces. What just happened? Did I touch something? Maybe. PCl3. PCl3 looks like this. Trigonal pyramidal. I'm leaving the lone pairs of electrons out on the chlorine. Okay, and then phosphorus and chlorine, we've got 3 and 2.1. So this is 3.0, this is 2.1, which means your difference in electronegativity is 0.9. So polar bond, polar molecule, because it's not symmetrical. So what intermolecular forces do I have? Dipole, and London dispersion forces. Okay, last one. That's ethanol. You have this right here.
Hydrogen.
Yep. It's got a hydroxyl group on it. That means it can hydrogen bond. And it would also be polar. It's got dipole forces and London dispersion forces. Are you good with that? Okay. Now, let's talk about the concept like dissolves like. Vitamin A is a fat-soluble vitamin. Vitamin A is actually a non-polar substance, and your fat is also non-polar. Okay, so that's why vitamin A goes into your fat. Now, vitamin A does not like water, so it would be hydrophobic, which means it just hates it. Okay, now if we're talking about vitamin C is actually a polar substance, and it has the ability to hydrogen bond with water. So it's water soluble. We say it's hydrophilic because it loves water. Okay. So when we're talking about this concept, like dissolves like, that means a solute will dissolve in a solvent if they both have similar types of intermolecular forces, and if those forces have similar magnitudes. Okay, so let's go on and talk about what happens when things dissolve in each other. So there are 3 things that happen. The particles in the solute have to separate from each other to go into the solvent. Okay, so that means you are basically breaking the intermolecular forces between the solute particles, and then you have to replace them. And then the particles in the solvent also have to separate from each other to allow space for that solute to come in between them. So you're also breaking the intermolecular forces in the solvent, and then you're going to replace them. Okay? And then lastly, the solute and solvent particles have to interact with each other. This is why they have to have similar intermolecular forces. Okay, so let's first talk about ionic solutes in polar solvent. An example would be sodium chloride in water. Sodium chloride is a salt. Salts are going to have cations and anions that hold them together. So here we have positive sodium ions and negative chloride ions. And the attraction between those ions has to be sort of broken, and then the water molecules will come in between those ions. Water molecules, you know, are attracted to each other by hydrogen bonding. You know that water molecules have a positive and a negative end because they are polar. And if you take a look at the next page, what happens is the cations in the salt, which is here, this is my sodium cation, that will be attracted to the oxygen end of your water molecules. That's where your permanent negative charge is going to be. So the permanent negative charge that's on the oxygen will be attracted to the cation. And these interactions are going to be ion dipole forces.